Picture this. You climb into a cab hundreds of feet in the air. Your hands are already sweating. The machine beneath you groans like it hates you just as much as you hate it. These weren't just difficult machines. These were specific models, real cranes with real names that made experienced operators dread showing up to work. Some shook themselves apart. Some killed without warning. Today we count down the 10 most hated cranes that operators dreaded. Number 10. Ruston-Bucyrus 71 RB. Kicking off our list is the Ruston-Bucyrus 71 RB, one of the larger models in the RB mechanical crawler crane range that dominated the European and British market through the 1960s. Ruston-Bucyrus, the UK affiliate of the American company Bucyrus Erie, was the dominant European manufacturer of mechanical crawler cranes, producing as many as 1,800 units per year at their Lincoln factory at their peak. Their range in the 1960s ran from the 22 RB, which was the most popular model assembled on a production line basis, up through the 30 RB, 38 RB, 61 RB, and the 71 RB as one of the largest in the line. The 71 RB was a rope-operated mechanical crawler crane offered with a variety of front-end attachments: lifting crane, drag line, clamshell, backhoe, and pile driver, among others. This versatility sounded impressive on paper. In practice, it was the source of much of the frustration operators experienced with this machine. The 71 RB inherited all of the fundamental problems of its era of mechanical crawler crane design. It was noisy to operate, difficult to transport, and slow to maneuver. These were not unique complaints for the 71 RB alone. As industry records from Cranes Today document, mechanical crawler cranes of this generation were broadly not popular with crane rental companies due to difficulty of transporting, assembling, and dismantling. Plus, they were slow to maneuver and noisy to operate. But the 71 RB, being one of the larger machines in the RB line, concentrated all of these problems at a higher level. The rope-operated control system on the 71 RB required constant physical exertion. Operators managed load movements through mechanical drum brakes and clutch systems that required significant hand and foot force to operate smoothly. There was no power assistance. Holding a heavy load at height for any extended period, waiting for a signal, waiting for ground crew to position, meant continuous muscular effort from the operator. On a long shift, this physical exhaustion became a genuine safety issue. When the hydraulic crawler crane revolution arrived in the 1970s and early 1980s, offering powered controls, smoother load management, and dramatically easier assembly and transport, the transition away from machines like the 71 RB was not mourned by operators. It was celebrated. Number 9. Manitowoc 3900. The Manitowoc 3900 is a name that carries deep nostalgia in the American construction industry. It debuted in the 1960s as a 60-ton capacity crane, and through the course of its production life, its capacity was progressively increased to 80 tons and eventually 100 tons through boom and counterweight upgrades and structural improvements. More than 1,000 units were manufactured, and yes, veterans of the industry remember it fondly. In the 1960s, the Manitowoc 3900 was the crane, as documented in industry accounts from Crane and Transport Briefing. But nostalgia and operational reality don't always match, and for operators who weren't experienced specifically with friction-style mechanical cranes, the 3900 was a machine that demanded a very specific and unforgiving skill set. The Manitowoc 3900 was a friction crane. That means the operator controlled the load hoist, boom hoist, and swing through friction clutches and mechanical drum brakes, not through the proportional hydraulic controls that later cranes would use. The key difference is this: on a friction crane, smooth load control depends almost entirely on the operator's touch and muscle memory. You feel the load through the levers. If you misjudge the friction, if your grip on the control is slightly off, or if the brake band is worn, or if the drum surface is wet, the load can begin to freefall. Uncontrolled freefall on a friction crane is one of the most dangerous situations in crane operation. A load that goes into freefall doesn't stop because the operator pushes a button. It stops when the operator successfully applies the brake, which under stress, on a machine with worn mechanical components, is not guaranteed to happen in time. The skill required to operate the 3900 safely particularly when lowering heavy loads or when the machine was older and its friction components were worn, was why the industry eventually moved to the 4100 with its improved braking system and torque converters, which, as operators of the era noted, allowed you to control the load better. The 3900's friction system, by contrast, was described as genuinely punishing to learn and unforgiving of mistakes, particularly for operators transitioning from other crane types. Number 8. American Hoist 90 White Knee. American Hoist and Derrick Company, known in the industry simply as American, was Manitowoc's arch-rival in large crawler crane manufacturing, based in St. Paul, Minnesota. Their machines were red, prominent, and widely deployed across the United States on major construction projects through the 1960s, 1970s. The American 9280 was a significant model in their crawler crane lineup, and it shared the fundamental character of all large American mechanical crawler cranes of the era. Enormous capacity on paper, but deeply demanding in practice. The core operational issues with the American 9280 centered on the same themes that plagued its generation: transport difficulty, assembly complexity, and friction clutch control. As cranes today's historical record documents directly, those early big mechanical crawler cranes were designed to lift, but not to be stripped down and transported. Thanks to hydraulics and modular designs, crane designers learned how to design cranes that could be easily broken down into manageable pieces, that in terms of weights and dimensions met road regulations. The 9280 and its siblings were the machines that made those limitations painfully clear. Moving an American 9280 from one site to another was a logistical undertaking that could consume days of work and require special permits for oversize and overweight loads on public roads. On a construction schedule where time is money, a crane that requires enormous effort just to relocate was a constant source of frustration for site managers and operators alike. The anti-two blocking problem was also a documented issue on the 9280. In fact, the New York City Department of Buildings specifically issued a technical policy and procedure notice in September 9, notice number 6, requiring anti-two blocking devices to be installed on both the Manitowoc 4000-watt 100-watt and the American 9280 and 9310 before certificates of operation would be renewed. Two blocking, where the load block is raised so high it contacts the boom tip, creating a sudden shock load that can damage or destroy the hoist system, was a known hazard on these machines that had gone without mandatory prevention devices for years. The New York notice also required drum clutch interlock controls to prevent more than one load drum from being operated simultaneously. Another safety gap that operators had been living with for the machine's entire working life up to that point. Number 7. American Hoist 93110. The American 93310 deserves its own entry because, despite being genuinely celebrated as the king of American cranes and one of the most versatile cranes ever produced, it became notorious for the specific conditions under which it operated and what happened when those conditions were not respected. Introduced in November 1972 with 355 horsepower and a 225-ton lifting capacity, the 9310 was a genuine landmark machine. Over 582 units were manufactured, and the crane could be fitted with a vast variety of attachments: lattice boom configurations, luffing jibs, tower configurations, and clamshell setups, making it one of the most adaptable cranes of its generation. But the 93310 carried the same fundamental issues of its class. It was a mechanical crane, friction clutches, drum brakes, and all the physical demands that came with them. The NYC Department of Buildings' 1988 notice, as described above, applied to the 93310 just as it did to the 9280, mandating anti-two blocking devices and drum clutch interlocks that should have been there from the beginning. More critically, the 9310's enormous capacity created a specific operational trap. When a crane can lift 225 tons, operators and site managers sometimes developed a false sense of the machine's margin for error. In reality, the 9310's capacity varied enormously with boom length, configuration, and working radius, and the load chart calculations required to operate it safely at different configurations demanded careful reading and exact compliance. Operators who relied on a rough rule of thumb rather than consulting the actual load chart for the specific boom length and radius they were using put themselves and their crews at serious risk. The 931's freefall capability, common on mechanical crawler cranes, was also specifically flagged as a concern by safety regulators. Some plants and facilities explicitly prohibited cranes with freefall capability from working on their sites because of the danger of inadvertent load release. For operators assigned to the 9310 on sites that were not freefall restricted, the constant awareness that the load could drop if they made a control error was a source of real, sustained anxiety. Number 6. Manitowoc 4000W 4100W, operated as a tower crane configured. The Manitowoc 4000W and 4100W are legends in the American heavy lift industry. Introduced in the early 1970s with a 230-ton capacity and widely praised as some of the most reliable crawler cranes ever built, operators of the era literally called the 4100 the Cadillac. These machines earned enormous respect in their primary crawler configuration. But there was a specific configuration of both the 4000-watt and 4100-watt that operators genuinely dreaded, the tower crane configuration, used extensively in urban high-rise construction in cities like New York throughout the 1970s. When converted to tower configuration, the Manitowoc 4000-watt and 4100-watt stood hundreds of feet in the air on active construction sites. And in this configuration, two specific problems surfaced consistently enough that the New York City Department of Buildings felt compelled to issue its 1988 technical notice specifically addressing these models. First, the anti-tube locking problem. In tower configuration, the hoist lines ran much longer distances than in standard crawler use, and the risk of a load block being accidentally raised into the boom tip was significantly elevated. Without the anti-tube locking device that was mandated in 1988, the consequence of tube locking at height, a sudden catastrophic shock load transmitted through the entire system, could cause structural damage to the boom or, in a worst case, trigger a collapse. Second, the drum clutch interlock. On these mechanical cranes, it was physically possible for an operator to inadvertently engage two hoist drums simultaneously. The manufacturer's own manual stated this was not permitted, but without an interlock mechanism, nothing stopped it from happening. If an operator in the confusion of a complex high-rise lift accidentally left a hoist control in an engaged position while operating another function, the consequences at height could be catastrophic. That these safety gaps existed for the years the machines had already been working in tower configuration before 1988 is a sobering fact. The NYC notice giving operators until October 31, 1988 to install the anti-tube locking devices or face non-renewal of operating certificates was, for many in the industry, long overdue. Number 5. Peiner SN 355. Luffing Tower Crane. The Peiner SN 355 was a German-built climbing luffing tower crane distributed in North America by American Peco Corporation. With a 192-foot reach and 17,000-pound capacity, it was built for serious high-rise work. On November 28, 1989, one collapsed in San Francisco's financial district during a routine climbing operation. The crane stood 298 feet tall. 4 workers on the climbing crew were killed. A fifth, a pedestrian on the street below, died when debris rained onto one of the city's busiest intersections during morning rush hour. 22 more were injured. California OSHA investigators concluded the cause was procedural failure, not structural. The crane itself hadn't broken. The climbing sequence had been performed incorrectly. That finding haunted operators for years because it meant the machine was only as safe as the crew following the procedure. Every climbing day was the day everything had to go exactly right. For operators working SN355s through the late 1980s, that was the day they thought about on the drive to work. Number 4. Grove RT9000s. The Grove RT9000 represents one of the most clearly documented cases in crane history of a machine that was too far ahead of its own technological foundation to work reliably. Grove Worldwide had been the pioneer and dominant force in rough terrain crane development since introducing the first rough terrain crane in 1957. By the early 1990s, Grove was pushing the boundaries of what rough terrain cranes could do. The RT9000 was their attempt to deliver a 100-ton capacity rough-terrain crane, an extraordinary claim for a machine type that had traditionally been limited to much lower capacities. The problem, as documented in Cranes Today's analysis of the rough-terrain crane market, was that the RT9000 was too far ahead of its hydraulic and automotive component technology, which proved unreliable. In 1993, Grove returned to a more conventional approach with its 100-ton RT9100, which became far more successful. What did unreliable hydraulic and automotive component technology mean for the operators who worked the RT9000? It meant hydraulic system failures. It meant the kind of downtime that halts a construction project and puts pressure on everyone from the site manager to the crane operator, who is expected to diagnose and explain what went wrong. It meant that a machine rated for 100 tons couldn't consistently deliver 100-ton performance over a sustained workday without component failures or system malfunction. Number 3. Link Belt LS218 outage. The transition from mechanical to hydraulic crawler cranes was one of the defining industrial shifts of the 1970s, and Link Belt was among the American manufacturers who moved into this space with new hydraulic lattice boom crawler cranes aimed at competing with the German and Japanese machines that were rapidly gaining market share. The Link Belt LS218H and its generation of early hydraulic American crawler cranes found themselves caught in a painful technological moment. As industry records document directly, hydraulic technology was in its early stages of development, and problems included limited power output, oil leaks, overheating, and poor reliability for operators. These were not abstract engineering problems. Oil leaks meant hydraulic fluid on the ground, which was an environmental violation and a maintenance burden. Oil leaks in the wrong place on hot components were a fire risk. A hydraulic system that overheated shut the crane down, sometimes in the middle of a lift, which created a genuinely dangerous situation. A load suspended while the crane waited for its hydraulic system to cool. Limited power output meant the crane's actual performance in the field was frequently below its rated capacity in real-world conditions. A crane rated for a certain lift that cannot actually achieve that lift without straining its hydraulic system teaches operators very quickly not to trust the published numbers. The reliability problems of early hydraulic crawlers were well documented enough that they actually extended the commercial life of the older mechanical cranes they were supposed to replace. Contractors who compared the theoretical advantages of hydraulics against the practical reliability of their well-maintained mechanical Manitowocs, and Americans often kept the old machines longer than expected, not out of nostalgia but because they worked more consistently. Number 2. Favco M440E Luffing Tower Crane. The Favco M440E, built by Australia's Favco Cranes, was a self-climbing luffing tower crane deployed on Manhattan's most demanding high-rise projects. In New York City, where occupied buildings sit feet from crane masts, a collapse doesn't fall into open ground. On March 15, 2008, workers were jumping the M440E at 303 East 51st Street, adding mast sections to push the crane higher. A rigger was using a damaged sling to position an 11,200-pound steel collar at the 18th floor. The sling failed. The collar dropped, struck a lower collar, destroyed the lateral support, and the 250-foot mast collapsed into the street. 7 people were killed, 24 injured. Sections of the crane landed on occupied buildings. The rigger's licenses were later revoked. The crane had been inspected by city officials days earlier. No violations found. 2 months later, another crane collapsed in New York. For operators climbing luffing towers in the years that followed, March 15, 2008 never left the back of their minds. Number 1. Potain MD 265 Tower Crane. Our number 1 most hated crane is one that brings dread of a very specific kind, not because the machine itself was poorly engineered by the standards of its time, but because of the operational procedure that every operator of a self-climbing tower crane like the Potain MD 265 knew was the most dangerous thing they would do on any given job, the climbing operation. Potain, The French tower crane manufacturer that came under the Legris Industrial Group's control in 1987 was the dominant force in European tower crane manufacturing through the 1980s and 1990s, and their MD series, including the MD 265, were among the most widely deployed tower cranes in the world on high-rise construction projects. Potain's crane sales grew from 2,100 units in 1998 to 2,600 in 1999, reflecting the enormous scale of their market presence. Tower cranes of the self-climbing type, of which the Potain MD series were leading examples, work by periodically jacking themselves upward as the building beneath them rises. The climbing process involves inserting hydraulic rams between sections of the tower mast, supporting the crane's upper works on those rams, adding a new mast section from below, then lowering the upper works down onto the new section and pinning it. It sounds methodical. It is in fact one of the most technically demanding and dangerous operations in all of construction. The reasons operators of Potain climbing tower cranes dreaded the climbing procedure are deeply documented in the accident record of this era. Assembly errors during climbing killed people repeatedly across the industry. When a climbing operation was performed with a worn or missing pin, an incorrectly installed collar, or a hydraulic ram that failed mid-cycle, the consequences were immediate and total. The crane's upper works, which could weigh many tons, would either fall or cause the entire tower to overturn. If you know a crane operator, or if you are one, drop a comment below. Which machine in this era gave you the most trouble? And if there's a specific model from 1960 to 2005 you think deserved a spot on this list, tell us. We want to hear it. Hit like, subscribe, and we'll see you in the next one.